Hi everyone. In this video, we'll try to simplify the basic understanding about the 5G sounding reference signal and also to deep dive into some details related to the parameters tuning and something called antenna switching and so on, and more details as well. So let's go forward. Okay, this is the main content of this tutorial. The first part we are discuss why do you need sounding reference signal. Second part, it's how to check whether the UE is supporting SRS or not as a capability point of view. Then we'll go through some of the main parameters of SRS. Then we'll be comparing the performance of SRS compared to CSI-RS BMI whenever it's being used for downlink beamforming or weight calculation. Then, okay, and lastly, we'll be summarizing the main recommendation or the main parameters which can be used to optimize or improve your network performance. Okay, next part. Now, why do you need sounding reference signal? Okay, as you know that we also sounding reference signal is used in uplink. Let's first clear the basic understanding of this one. I will recall what it means by SRS. SRS is sounding reference signal. SRS is being transmitted in the uplink through the UE and it's being measured by the BTS to estimate the uplink channel propagation, uplink radio condition, because here the BTS can measure the signal strength, uplink signal, and so on. So accordingly, it can be used for uplink channel propagation estimation and also link adaptation for the MCS. For example, it can tune the MCS for b-SRS and so on. So this is the main purpose for this one. So once it's having this uplink channel propagation, it can now start making scheduling and assign the needed resources for the UN in order to start upload. So this is the first point about the SRS. And what is the characteristic for SRS in 5G? What means by characteristic? Characteristic means like how many samples can be used, kind of frequency and so on. Okay, in 5G, we can use one up to 4 samples for SRS can be used for SRS. Okay, and the bandwidth can use the complete bandwidth up to 272 RBs, can be fully channeled, can be assigned to SRS. Okay, here in this figure, I'm just showing this is for the special slot where we have 2 guard band and we have BDCH. The last 2 samples here were being used for SRS, but still the SRS can be assigned in the uplink slot as well, which is coming after the special slot. And as you can see here, there is one important point to highlight. I mentioned that the SRS can accommodate or can take the full channel bandwidth, but individually is not actually using the full RB. There is some related parameters which is controlling the assignment. This will be discussing in the parameter section. Okay, so now why do you need sounding reference signal even though we have DMRS, demodulation reference signal b-SRS, which still can make the same job, right? Still can demodulate the uplink channel propagation, right? Okay, first of all, because DMRS is not available whenever there is no data transmission. What it means by this? Means that whenever I don't have upload or b-SRS, there is no DMRS. So this means it's not available all the time. This means I cannot make the estimation. Just like it will not be timely updated and so on. Second part, that the DMRS is associated with b-SRS. What it means by this one? It means that if, for example, if I have 10 resource blocks assigned for a specific UEs to start making upload, this means the DMRS will be using only 10 RBs. This means I cannot make the measurement for the complete bandwidth. I'm just making for a very small part. So maybe that my measurement will be incomplete in some cases. It will not be that accurate, which means the DMRS don't extend beyond the current data transmission allocation for the b-SRS. Okay. Now, and one more last point that actually SRS is not only being used for uplink channel aware scheduling or uplink channel propagation estimation, it can also use for downlink channel estimation. And this is very, very important because as you know that we have in TDD, the frequency in uplink and downlink is same, right? We have this concept which is called the channel reciprocity. Channel reciprocity means that you have the same downlink and same the TDD is using same uplink and downlink frequency. So in this case, we can estimate the downlink channel through the uplink, for example, SRS. This is the case. So we can still use SRS to estimate the downlink channel propagation. Then we have something called non-codebook and codebook. This is something related to b-SRS weight calculation and so on. Non-codebook just simply it's assuming that there is a channel reciprocity, so it's using the downlink measurement to estimate to make a pre-coded to calculate the weightage to the SRS and sending to the BTS. So the UE is doing the calculation here. The code book, it's assuming there is no channel reciprocity, assuming there is no channel reciprocity. In this case, the BTS need to calculate the weight itself, the weight for the BUSH. However, it's just using the SRS to the ports used by SRS to be used by the BUSH. This is the main purpose of this part. Last part is about something called uplink beam management, which actually not really needed, but this uplink beam management, this is assuming there is something called there is not something called beam correspondence. Beam correspondence, that, and this is the normal case scenario which you have it now in the majority of the network. Beam correspondence means what? Means that, for example, once you identify the best beam in downlink, it can be used for uplink. This is beam correspondence. And so in case you don't have it, this means you need now to use the SRS to find the best uplink beam, which that's why we call it beam management. Okay, moving forward now, the second part here, how to check whether the UE is supporting the SRS or not. Actually, first, there is it's already clearly mentioned in 3GPP, and I will explain this part. But let's first confirm one point. What means by this? Okay, and why do you need this? Actually, I mentioned one point that SRS is being used for downlink channel estimation, right? Downlink channel estimation. But it cannot use for downlink channel estimation if it's not supporting this part, if the capability is not supporting something called antenna switching. What it means by antenna switching? The SRS should be there is two conditions for downlink channel propagation that the use must meet. One of two conditions in order to transmit the SRS and in order to SRS to being used for downlink channel propagation estimation. First part, that either to have equal number of transmitter and receiver for the UE for antenna for the UE, or if it's having, for example, let's say you have only one transmitter and two receiver, this transmitter can be antenna, it can be switched between the two receivers, so we can transmit still to SRS through the two received antenna in the UE. This is called antenna switching. So in this case, for example, T1, this means it will be antenna switching between the two receiver antenna will be transmitting to SRS. Here will be transmitting 4 through the four antennas, and here 2 will be transmitting through 4 as well, and here 2 will be transmitting through 2 and so on. Through 2 and so on. Okay, so now the first part you need to check, for example, if you're doing testing, you need to confirm and so on, whether it's supported or not. You need to go to the UE capability message in layer 3 and check this part, supported SRS T export switch. If this part showing here not supported or is not available at all in the message, this means this particular UE is not supporting antenna switching. This means this particular UE cannot report SRS, so it cannot be used for a channel estimation down. This is in case you are doing trials, and I will also cover more details about this part in the future. So you will find this part under supported combination, and it's called supported SRS T export switch. Okay, moving forward, this is just to explain more about this antenna switching thing. Okay, here I'm giving on the left about the antenna switching, something this for the example for T2, 2T and 4R, or 2 transmission and 4 receiver. Okay, here I'm the blue one, I'm assuming that I have 2 transmitter, right? And this black one, I'm assuming that I have 4 antenna for the receiver, right? So what I will do here, the first part in the first symbol here, will be done in 2 different symbols. Let's assume this is symbol 6. In symbol 6, the first part will be using the first 2 antennas, 1 and 2, or 1 and 3. Okay. Then in the next symbol, it will be switching. It will be transmitting again the SRS through the other 2. So it will be switching from here to here, and from here to here. So in this case, you are utilizing your 4 receiver to transmit the SRS and so on. And this is the capability which is called antenna switching, which you need to confirm with the capability message. Okay, the point number 2 here, channel sampling without antenna switching. Without antenna switching, this is assuming that directly, just straightforward, that you already have equal transmission and receiver. So in this case, you can just directly transmit the SRS, and there is no problem in this part. This is where we call without antenna switching. In case if your UE is not supporting, is having less number of transmitter compared to the receiver and not supporting antenna switching, this means this particular UE cannot transmit SRS and cannot use for downlink channel estimation. Okay, moving forward now. This is here to discuss about the SRS main parameters. The figure on the left, I'm just showing the layer 3 message for our serial configuration, which is listing all the main parameters for SRS. We'll discussing all of them in details in next slide as well. So the first part here, you can see in the first part of the RSC message, we have something called SRS resource set. This is SRS resource set. This is actually this SRS resource set. You have up to 16 resource set ID. This resource set ID, it's having a subset of another parameters under it called SRS resources. And why do you need different or many SRS resource set? For example, let's assume that this is the main parameter for this one. Let's assume that you have two SRS, one SRS for beam management or uplink beam management, and one SRS, for example, for downlink channel estimation, which is, we call it antenna switching. Okay, we call it antenna switching. So in this case, if you have two different missions, you need by the SRS, you need to transmit two SRS resources. You need to have the source I set, for example, 0 for beam management, and the source I set, for example, 1, for example, for antenna switching, or antenna switching is means for the downlink channel estimation. That's why we have many SRS resource set. As I told you, it's up to 16, as I remember, or 0 to 16, yes. This is the first part. Here it's having some common parameters which is can control the overall transmission of the SRS. Okay, what is this parameters? We can go through here in the detail. First part, it's about the resource type. Whether this SRS is aperiodic, semi-resistance, or periodic. We'll be discussing this part in the next slide and more, just to try to visualize and just to understand what is the difference between all of them. Then it's about the usage. This SRS resource transmission is used for what? What kind? For example, uplink beam management, or codebug, non-codebug, which is both used for BOSH or uplink channel estimation, or downlink channel estimation, which is antenna switching. This is the type. Whenever the usage, for example, here you mentioned codebug, this means it's used for the uplink channel estimation, where we don't have channel reciprocity. We're not considering channel reciprocity. Then you have the alpha and B naught or B0. Alpha and B0, this is actually both are used for the power control. So, for example, B0, this is, I will just to give you a brief about it. B0, whenever you have higher value, this means whenever you increase the value, this means your uplink power will going to increase, and there is a probability to improve the SRS coverage and the SRS quality or RSM. And the opposite for the reducing the value. But however, also increasing the value can increase the interference of 20%. So you need just to be very careful whenever you're optimizing based on your network condition. Then, as I mentioned, there is something called SRS resource, which is subset of the SRS resource set. Simply, this one is having many parameters, which is being controlled the resource allocation for the SRS. What it means by this? Okay, first part, for example, here there's something called transmission comp. There is two values, 2 or 4. As I told you before, the SRS can be transmitted over the full bandwidth, over the 272 RBs as example. But the individual EE is not using the full bandwidth. It's using a specific subcarriers within this 270 RBs, and this specific subcarrier is being defined by this transmission comp size. I will explain in the next slides as well. Then we go through the resource mapping. For example, what is the start position, start frequency? What is how many number of symbols? How many number fields used by this individual EE? For example, 1, 2, 4, and so on. Then there's something called repetition factor. Then the last part, it's about the frequency hopping. In other words, this is actually a very important one. This is just to define whether you are going to use the full bandwidth for the RBs, or you want to, for example, use only the half bandwidth for this particular EE. What it means by this, I will also explain in more details, but let me give you a quick brief about this part. For example, if the UE is transmitting the SRS over the 270 RBs, this means the SRS power is being distributed over the 270 RBs. Let's assume you change it to half bandwidth. Half bandwidth means that instead of the full bandwidth, you will be using the full half RBs. This means your power can be doubled. This means your coverage can be much better. You can improve the coverage, especially for the edge user. This is the main idea. I will be showing this in more details, and let's go through forward just to try to cover these parameters in more details. Okay, this is the first part about the resource type. The resource type, actually we mentioned that we have 3 types: aperiodic SRS, semi-persistent SRS, periodic SRS. The first two, actually, it should be triggered through the BTS. The GNLP should send some indication or instructions to the UE to start reporting the SRS. For example, the first part for aperiodic SRS, it needs BDCH to send downlink control information to the UE to ask him to report the SRS, and it can be used for different purposes, like, for example, uplink resource allocation SRS, or downlink resource allocation, or also power control. You need to, for example, increase the power for SRS. This is in case. So this is aperiodic. This is event trigger. BTS will decide based on the requirement. And the same for semi-persistent scheduling, but this one is being sent through the MAC control element, and MAC control can activate or deactivate the SRS, and this is usually sent in the BDCH channel. The last part, which is usually used most of the time, is called periodic SRS. Periodic SRS, This means there is no instruction needed from the BTS or from the GNB, as long as already the configuration will be delivered from the beginning, informing the UE when the periodically report the SRS. And as you can see, it will all the time be reporting the SRS based on a specified intervals and so on. So this one doesn't require any triggering condition. Just directly it will be reported by UE based on the previous delivered configuration in the RRC configuration message. Moving forward, here the SRS, this is for the transmission comp type. As I mentioned to you, that the UE, the SRS is being transmitted over the full bandwidth, but each individual UE is not using the full subcarriers within the RP. Assuming that you have 270 RPs being used, the UE is not using the full. The user is using specific subcarriers. For example, if you mentioned that you have transmission comp size 2, this 2 means that every second subcarriers will be used by the UE. For example, if it started here, every second subcarrier will be used, and so on. First UE. Here I'm using this 2 symbols and so on. This means in this particular symbol, for example, let's say symbol 7 or the symbol 14. Here in this one, you can have 2 UEs, right? And you can have 2 UEs. So and another thing here, that there is also something called cyclic shift, that you can multiplex another 2 UEs within this one, within the same frequency. This means one symbol can have up to 4 UEs being used as SRS. But in general, transmission comp size is controlling the subcarriers used within the RB by the individual UE. So transmission comp size 2 again, using the every second subcarrier. And transmission comp size 4 using the every fourth subcarriers after the first one. So what is the difference is why we have this one. This one was not available before in 4G, only this one was available in 4G. We need this one in case if you need to increase the capacity of SRS. You have a congestion and then you need to increase the capacity, so it will be charged to transmission comp size 4. So this one can free some resources for other users to start using the SRS. This is first one. But there is associated drawbacks for sure. Before this one was using almost 50% of the RP resources, right? So it's having like it's sending the SRS through most of the bandwidth or 50% of the bandwidth. However, this one is much less compared to the others. So the init B will not having will have a less measurement for the bandwidth. So maybe it will miss some interference or whatever. So it will have kind of incomplete or inaccurate information sometimes, or less information, not complete information about the SRS or about the complete frequency bandwidth and so on. This is the transmission comp time. Moving forward, this is just summary for whatever we have explained. Moving forward, okay, frequency hopping or c-SRS and b-SRS parameters. As I mentioned for you, this is very important because this is controlling whether the U is going to operate, the individual U is going to operate with full bandwidth or half bandwidth, or even less than half bandwidth. So the first table here, this is 3GPP standardized table, which is showing these two parameters, a combination of these two parameters. For example, the first column here is showing the c-SRS. This is up to 0 up to 62, as I remember. So this table I just take some of, I just used four rows of out of it, and you have this b-SRS as well. So the combination of these two parameters, you can identify how many RBs. For example, this MSRS, this is equivalent to the number of BRBs going to be transmitted and SRS by the individual UE. For example, assuming the c-SRS value is 30 and b-SRS is 0. This means you have 128 as a full bandwidth in this particular case. So the UE can transmit, as you can see here, this is assuming this is a frequency. The frequency. In this case, we can transmit the full SRS, use the full RBs at one just directly. As you can see here, assuming this is the complete channel bandwidth, they use transmitting in the same sample the complete the full SRS using the full bandwidth. Okay. Okay, so this means your power will be calculated over the full bandwidth. So what is the difference now? If, for example, now let's assume that I want only use the half bandwidth. Okay, in case you want to move the half bandwidth, you can change the SRS value from 0 to 1. So in this case, instead of using 128, you'll be using 64 RB only. So you can see in the first symbol here, you transmitted half the bandwidth, 64 RBs. This means your power will be doubled because the power which is being utilized before in the complete full bandwidth now will be utilizing only in the half bandwidth. So you can have maybe up to 3 dB improvement. So this can improve your uplink, your SRS coverage and quality by around 3 dB. So in this case, but still there is some associated drawbacks can be observed, not necessarily, but can be observed, that still you are not reporting the full bandwidth. You are reporting, yes, the remaining half in the second symbol, but maybe you will have a variation during the reporting the second half, during the second half cycle. Maybe this the already the radio commission will change and so on. So this might report inaccurate information in this particular case. So this is the differences. So you can use half bandwidth in case if you want to improve your uplink coverage for SRS coverage. So you can convert or tune this parameter, and this is very important and very needed, especially for the edge users. And you can check whether your vendor supporting dynamic allocation or not. Moving forward, the last part here that we are going to compare between the SRS downlink channel estimation or downlink beamforming calculation or width calculation using SRS or BMI, CSI-RS and so on. Okay, the first part here was mean there is SRS weight. SRS weight and SRS weight here, as you can see, the UE is directly reporting the SRS or transmitting the SRS in the uplink, and directly the BTS or the Junior B will all the time can measure the SRS and can make the width calculation, and can, based on this one, it can identify the required beam direction and so on, and can make the beam forming towards the needed UE with the needed beam and so on, can make the beam direction and so on. So this is the first part. Here, as you can see, first part, the BTS first, this is assuming there is no channel reciprocity and showing that you are using CSRS or BMI weight. Here first, the BTS need to report the CSI-RS, right? Then the UE will need to measure the, here this is the UE, the UE need to measure the CSI-RS. After the UE measure the CSI-RS, it will be reporting BMI, rank indication, CQI, brief-coding matrix, rank indication, and channel quality indication, and so on. So after this one, the E node B now, or G node B, sorry, will start the calculation, weight calculation, and after it will assign the needed beam to the UE and so on. So it will assign the beam and so on. So in this case here, you can see you have more process here. So this one actually is not timely updated like the SRS. The SRS is timely updated. BTS can all the time measure the SRS, so it can give quicker feedback and also more accurate feedback, timely feedback. That's why in general, SRS is recommended in a good radio condition, and BMI is conditioned in the cell edge, where you will have a very cell edge will have a very weak uplink coverage. So this might impact the calculation of the SRS. You cannot estimate really the downlink at that case. You will have imbalance between downlink and uplink, so you cannot estimate the downlink in this case of edge users. So in the edge users or the far edge users or edge coverage, you need to rely on BMI weight. So we use both of them, but it's recommended as well to use SRS along with BMI weight. Okay, as a summary for the parameter tuning and network optimization, you have three main inputs you can play around. First one is the B0 or B0, which can be tuned based on the network requirement. It can be increased if you are looking to move, for example, the SRS coverage. Same for the frequency hopping parameters, or let's say the full and half bandwidth. You can tune the b-SRS in order to have to convert it from full band to half band in order to double your SRS coverage by around 3 dB. Then in the last part, it's related to the last part we have just mentioned, that the comparison between SRS and BMI. You can try to tune the SRS in order to be working for the cell center, so it can give you much better performance, especially for downlink throughput and so on. And that's it for today's tutorial, and thank you very much for your time. And please, if you like the video, subscribe to the channel and press like, and also drop your comments if you need to cover any other topics, and please share it with your friends. Thank you very much.